Okay, today we are going to talk about some ProfiSafe offered from Festo. Uh, ProfiSafe is on their CPX manifold, and the ProfiNet node is FB33 that we're using. In my case right now, I'm just going to use an older S7-300 PLC with failsafe in it, and I'm going to use TIA Portal, and I'm going to show you how to commission and get this card here, the safe output module here, this FVDA-P2. It has 3 channels, channel 0 through 2. Channel 0 operates and controls the backplane of the CPX and allows power to get to the valves on the backplane here, where this yellow yield sign is. If you look in the user manual that Festo offers, to be a little more to the point about what I just mentioned, this is the FVDA-P2 module. There's a power supply coming in to the bottom module right here, to this ProfiNet module, and then it goes to the right side. So the first thing you want to do is configure the hardware of the CPX. So if you look at the layout here, let's zoom in a little bit here. So each one of these safety modules, this one on the left here, this F8DE, it is a safety module, therefore it needs a address in the network, and same thing with this output module here, it needs an address in the network. If you go into the user manuals for Festo, it gives you an overview, and I've kind of marked up my own PDF here. And basically, when you're looking at the module itself, the module, when you're looking at the assembly, you actually have to remove the top cap, whatever that may be, the KL or KJ, whatever they call them, or this one here, and you get to the electronic module, and then right here on the electronic modules where you see the tiniest of all dip switches, or DIL switches they're calling it. And so another view here, basically when you scroll in here, you'll see that right here there is a dip switch that looks like this here, and this is where you set the dip switches as a binary setting, and that must match your configuration in your TIA Portal project. And the same thing goes for the input module. They're both in the same location, both same concept. Okay. Okay, so I've opened up the manual for the input block, and this is to show you that I'm going to have an e-stop wire to the first channel, and I've chosen to use what is called function mode 6 or 1002T, which is equivalent with clock signal monitoring. And when I am wiring it to the KL card, that means that the e-stop is wired in this manner right here. So the circuit leaves on the TO, comes back through on the E0, or vice versa, I mean, and then leaves on the E1, comes back in the T1. And these are the pin numbers. So that's how I've wired the e-stop. And next thing I have is the module to the 16DE here. The top left, channel 0, I've got an input wire to the very first input, which we'll discuss later. And as I already said, the FVDO, or the output, ProfiSafe output card, I don't have anything wired to these 2 external channels here, the 2 on the left here. I'm just going to control the channel 0, which is going to go to the VTSA, because that's the most common thing. And the last bit of wiring is at the bottom of the terminal here. When I have the supply port on this ProfiNet node here, I need to wire it. So I'm using this the 7/8 5-pole here, and I've got it wired as as shown right here. So this right here. So not the one here, but this one right here. So 0 volts are at pin 1 and 2, and 3 is grounded. 4 is the electronics and sensors, and then 5 is the load, which will be what the channel 0 is switching. And that's it for the wiring. So I'm just going to close this here. Now, Festo offers a tool from the website. Okay, and the tool. So let's go to the website. Festo.com, www.festo.com. Click on Support Downloads. There'll be a search window. Type in 3 letters, FMT. Hit the Enter button or hit the Find. Go to the Software tab, and there is some software here. Version 4.2.1 is the main body engine, and then there's an update 14. So you download this, install this, accept all defaults, and then install the update 14 on top of it. That's at this time. This could change, but basically you want to get the latest FMT or Festo maintenance tool and install it and open it. So the next thing I'm going to do is I'm going to open it. So okay, so it's installed. I'm going to click on Run. It opens up with the splash screen, and it comes into this wizard here. You obviously want to establish a connection to the valve. At this point, your Ethernet cable is connected to your PC, which I'm not going to show you how to do. I'm hoping you know how to do that. And you're on the same subnet. And you click on the next button. We're going to do a search. I've given the ProfiNet node an address already. Hit OK, hit Next, Finish, and we're going to go in. So it's uploaded. All right, so I have, so I'm online right now, and I've uploaded. I've also saved the project as project name, and to show you the properties real quick in case you are interested. So I've got a Rev2 input safety module. Has this much inputs and outputs allocated. The digital safety input module. Hit OK. The next module is the 16DE, which is this type code right here. And it's a Rev9. The ProfiNet node. This is the settings for the ProfiNet node, which you would do this yourself. You could do this using the Siemens CPU portal. I can show you that later, or maybe in some other video. And the module here is a CPX-FB33. And then we have the safety output module. This is the configuration right here. The PROFIsafe address right here, that's important. So if you take this hex value, multiply it, or convert it to the decimal, you'll see that you need to match that. I'll get into this later. But basically, this is a read-only. And this module here is the safety module. 6 in, 6 out, it's a Rev2. And going back to this input module here, where is it? I thought that they had a... well, I thought they had an address here, but I guess they don't. But I think you can access it through some backdoor things. But anyway, I've shown you where the diff switches are on the module, and we'll get into that later. So this is what we have. We've got a VTSA as well. This is the pneumatic interface set for 32 total valves, or 32 total outputs. Okay, so now we want to start up TIA Portal version 14 because we've got the hardware configured, we've got the FMT uploaded, and we're monitoring. So I'm going to start up TIA Portal version 14, Service Pack 1 on this computer. Okay, so say new project. I'm going to give it a name. Save it where you would normally save it. Now, TIA Portal is a little bit slow when it comes to software, so I'm just gonna. You'll notice that I'm trying to skip over some delays by going so. So the first thing we got to do is add a PLC to the project. All right, so I have the catalog article number, so I'm just going to put this in here and do a search. So on the right-hand side, I'm just going to do a search. It'll find the unit. I'm going to drag that, let it go. All right, double-click on the PLC it just added, and I need to finish configuring the rack. This is my 16 input module, drag that there. And then I have I've got an analog input output card here as well. So that's saved. Okay, so let's focus on the PLC. So I am going to give this PLC a name. And you'll see here that the safety is enabled. I'm going to keep the default values. And then for protection, I'm going to go full Monty here. I'm going to put in a password. I don't use anything without passwords. Of course, it has to match. And for the ProfiNet interface, we need to add a new subnet. And then also give it an IP address. Save the project. Okay, so now we've got the base PLC. There's our network. And we go into here, go into program blocks. Now, to avoid program stop mode and things like that, I'm just going to add a couple blocks here. So if you read an article in the Siemens website, you'll find out that you need these interrupt routines. Otherwise, if you encounter a fault, basically puts the program in stop mode, and you'll be pulling your hair out. So I'm just going to add all these real quick. Just accepting the defaults. Okay, save. Now to finish off the safety, there's the safety administration here. And you'll see here that there's some defaults here. This is all good. And for access protection, you want to set it up. Again, I'm going to use my same password. The OK button. So that's done there. This is just telling you that this interrupt routine here is calling the main safety and so on and so forth. So we're all good to go there from a safety standpoint. The one thing I like about TIA Portal is it actually does all the safety downloads for you. Just be careful that you use a password with all your safety when you're using the S7300. Otherwise, when you go back to your older software and try and get online, if you've never used safety in the PLC, it'll ask you for a password that doesn't exist. At that point, your PLC is a brick until you get it to a distributor where they've got a a Siemens computer. Believe me, I've done it. Okay, so the next thing we want to do is add the Festo CPX manifold. And the first thing you want to look at is downloading the GSDML files from the Festo website. So you go to the Festo website where we left off, same spot where we were searching, type in CPX-FB33, search, scroll down here, and there's your ProfiNet. There's your latest and greatest. You'll download this and install this. I'm hoping you know how to do that. And, well, maybe I should show you that too. Hang on. Okay, so what you've done, you've unzipped the XML files, or the GSDML files, and now you come up into your menu system to install it. Under Options, Manage General Station Description Files. You come into here, you put a path in. If you don't have the right path selected, there'll be nothing down here because you're not pointing the right path. So you basically select the path here. I've already done that, and you would basically, it says it's already installed because it is. You would basically click on that and say install. Okay, make sure that you're seeing everything here. So this is the XML file that I'm using, 2.31, and so forth. So I'm just going to cancel that. So now it's installed and your catalog's been updated. Now you come into where is it here? ProfiNet IO, Valves, Festo, here and here and here. So the next thing you need to look at is on the top of the FB33. So you have your power source right here, and on the top of the FB33 you have a label from Festo, and the label, it'll say CPX-FB33, and then below that part number, and to the right of that it'll give you a rev number. My rev number is a rev number 24, I think it is. Yeah, rev number 24. And that's important at this point in time because the project, you need to specifically select a rev number. So I'm going to move this up here a little bit and scroll down. So down here, Rev 12, it says, Rev 12 takes you up to Rev 18. The Rev 18 goes from 12 up to 18. Rev 20, hey, that's the one I want. 20 up to Rev 24. And then 30, I think, is Rev 30 or higher. So this right here, when you drag this in, that's going to depend on your hardware. And if you go back to the Festo Maintenance Tool project, and you come into the 33 here, and you go to the left side, you will see here that it also gives you the revision number. Okay, so it's really important that you select the right GSDML file to begin with, otherwise you'll have some issues. So at this point, I'm just going to drag it over and drop it in. And first thing I'm going to do is assign it to the interface on the PLC over here. So either I drag it, I can drag it like that, or I come down here and just click on that and it connects. So now we need to configure what I've shown you already here, like the modules here, what is here, and what is also being shown right here. So we need to put all these modules in manually. At least that's the only thing I know how to do. So we go to CPX-P safety. In this sample here, I'm going to use the bits because you have to word or bits. I'm just going to use bits. It's going to drop it in there, and you can see here you have IO tags. If I use the word, it wouldn't have IO tags. That's why I like this. So I can populate this later. And the next module is the 16DE-D. So the 16DE-D, digital inputs, DID, drag that in. And then the next module is the Fieldbus module. And this right here, there's 3 options to choose from. And on the front of the FB33 module, there are some DIL switches. So I've downloaded the user manual for the FB33, and this is an overview here. The DIL switches I just referred to are on the left-hand side here. Okay, let's see if I can find a bigger blow-up for. Okay, page 26 of 160 shows the DIL switches better blown up. So on the left-hand side, we've got the bus node operating mode. On the right-hand side, we've got diagnostics mode. In my case, I have all dip switches down. And what that means is with DIL switch 1, if they're both down, which is factory, I'm in remote operating mode. I'm not going to get into what operating mode remote controller is. That's basically when you have a Festo PLC sitting next to it controlling the I/O. But we're in remote I/O mode here. So the first switch is off, and then the second switch is for diagnostics. Like I said, I'm using the factory setting, which is no diagnostics. I'm not going to get into that detail for any reason. And you can read about the rest of the stuff and decide if you want to use some of these other things like status and so on and so forth. So there's status and then there's STI. So in my case, I have nothing. So I'm going to drag this in here. And then the last module, we go back to the picture. Last module is the FVDA. And the FVDA is right here. And I have a P2 module, not the older P. So I'm going to drag this in here. All right, and then I'm going to find the valves. So VTSA, and I've got a configured DIL switch 4 if all 4 are on, and drag this in here. So the one thing I did not show you earlier is that this thing here with the exclamation on it, this is what they call a pneumatic interface, and there's some dip switches in there. And let me see if I can find a picture to show you what the DIL switches I have. Okay, so I've downloaded this manual here for the VTSA pneumatic interface, and just zoom in here. So the pneumatic interface has this LED here, and then has these dip switches. And if you take the top off and look in closer, it looks like this right here. And then here's some examples. So this right here on the right-hand side is the default setting from the factory for the VTSA, which allows for 32 output valves, 32 outputs for valves. And the idea is that if you only have 8 valves, for example, and you want to expand on that later, you don't have to change your I/O size or affect where things are. The allocation is already there. All right, so we've got all the hardware in, and the next thing we need to do is I mentioned the fact that the DIL switches on the modules needed to be a match to the code. So if I go back to my picture here, I referred to this module here, and on each module you had set a unique address for the safety network with the DIL switches. So now we need to match that. And in my project, I will show you what I did here. So this one right here, so if you click on safety here, there is a destination address. That's got to match. So in my case, I set it to 61 for my input module, and on the output module, I set it to 60. So now we are configured as far as the basics go. Depending on your network speed and your PLC, you may or may not need to sort around with the watchdog time here. And the same thing goes in the safety administration settings. I'm not an expert in that area whatsoever. I just that's up to you guys and your Excel spreadsheets to figure all that safety data out. There's a very handy 600-page manual from Siemens that talks about setting up safety that you can find on their website. And then there's a couple of 150 to 200-page corresponding or complementary manuals. So happy reading. What do I do next here? Okay, so save the project and compile everything. And you'll probably get a fault right away because I have some modules here and there's nothing connected, but let's see what happens. Yeah, so I have some faults. So this just says, hey, I have nothing connected to these modules here. So until you do further programming, just ignore these faults or these warnings. They're really nothing to be concerned about right now. And let's just keep moving on here. At this point, I want you to be certain that you have two manuals. So amongst, so there's the 33. You would download the ProfiNet bus node manual right here. This is the manual for the ProfiNet FB33 module. And then for the pneumatic interface, if you're interested in that, it's this one right here. And for the ProfiSafe input card, this is the manual here. So you download this, which I'm going to open up and show you in a minute here. And the ProfiSafe output module has this document number here. So you download that manual. And additionally, which I always forget, if I go back to CPX-FB33, hit the enter button, you'll find that Festo has an expert knowledge page here, and I do believe they have a decent technical, do they have something here? Power supply. Maybe it's not this one, maybe we want, so there's nothing on the FB33, but FVDA-P2. Maybe, okay, so it's not for that one. So it's the FB, what is it here? So it's F8DE. This is the input module. So if you go to expert notes here, programming F8DE into your portal. So this is another resource for you. These technical notes from Festo are pretty top notch and detailed, but it doesn't cover everything, which is why I'm doing this video. It just covers their product. So now that you have all the manuals, I'm going to start with the, well, let's start left to right. So let's open up the input module. So the input module has process data, and within the function, within the process data, there's inputs and outputs. The input data is simply reading the e-stops and whatever else you have hooked up to the inputs, and the output data configures the module. So we talked, or I said earlier that I wanted to use the 1000 T equivalent for mode 6 for the, and you have to actually set that. So in my case here, these bits in byte number 2 is what I need to write the data to set mode 6, binary to decimal conversion. And then there's a couple other things here. So what I'm going to do here is go back to my PLC program, and the PLC program, click on properties, IO tags. This is where the the tags exist here. And right here, sorry, wrong card. Okay, so what I want to do here is associate tags with the input addresses here. So I'm just going to quickly add some code, add some tag names here to match that data profile. Okay, so I've added the names and some descriptions, and the idea is that, you know, they match. For example, the output bit 0 and 1 are operating mode and acknowledge error, and whether passivation is active or not. And then further on down at the bottom here, I've got my function modes. So I'm going to use these bits throughout the code. And now we're going to move into the I/O for the ProfiSafe output card. So in the ProfiSafe output card, again, there's outputs and then there's inputs. So there's input data and then output data. The output data is where you turn on your channels. You know, you've got, if you flip this bit on here and you're able to force the safety I/O, then you would turn that channel on. And then they talk about being able to disable the test pulses for the channel 1 and 2, the external ones, which we're not going to concern ourselves with. And then acknowledgement for reintegration and so on and so forth, data direction, passivation. So right now I'm just going to populate the inputs and outputs with what the text is right here. I'll go back to my PLC code here. Okay, so we're going to select the output card, and I'm going to type in some names. Okay, so what I've done here is I've added some names, some comments, and basically that's matching what I've got here. So the output data channel 0 enables byte 0. If I go back to the code, channel 0 output is channel 0 power enable. And power status is on the first input. If I go back to the input, you'll see that the status is right here on the first byte. Okay, so now we've added real names to the real I/O. That's how I like to do it. I'm going to save the project and just going to quickly compile it. Should still get the errors, but all right. So the next thing we're going to do is add some code, and this sample code here will be accessible in the YouTube video. So below the YouTube video, there'll be a link to Dropbox, which will have anything I can put in the Dropbox area for you to help you accelerate your job here. There's one more thing I wanted to do here. I don't like the default names, so I'm just gonna have a certain naming convention I like. So you see here that this changes, and this also changes here, and this one over here. That's right there. Okay, so the next thing I'm going to do here is I know I need some safety tags, so I'm going to make a global database. Create an F block, and I'm going to call it safety DB. Hit OK. Add that in. And I'm going to add some tags to it. See how bloody fast I can type? Hee hee. So I've added the tags, save the project, and now I'm going to start to add some code. So this is the main safety routine here. and I'm going to copy and paste in some code, and then I'll explain it. So I'm just going to delete this rung, hit the delete button, Control V, paste in all the rest of my rung. All right, when I paste in some rungs here, I've got a couple of faults. And I've got a couple of faults because I pasted in the code before I added the tags at the top here. So I'm going to add some tags here. Add some static tags here. And then add some temp tags here. Okay, so the tags exist, and let's see how many faults we have. Let's collapse them all. So we got module 8 as a fault. The acknowledge push button. That's because in the input card I forgot to add something here. Give me 1 second. So if I go to here again, click on this card, open this back up, properties, IO tags, forgot to add the push button. So this is my acknowledge push button for everything. So now if I go back to my safety program here, collapse that, collapse this. I got rid of that fault. And then we have 2 other things here. So for some reason, whenever I paste in code, it doesn't want to create these data blocks. So I just go like this and hit OK. Automatically adds it for me properly. Same thing with this feedback. Okay, so just added these right here. There's some, okay, so collapse them all. So I have no faults in my code. I'm going to save the project. And then I'm just going to do a bunch of compiling here, rebuild all for the hardware, and then compile and rebuild all for the software, and it should have no errors. No errors, no errors, no errors, please. Awesome. Okay, so let's explain the code a little bit here. This is a 300 PLC, so I can only put 1 rung in each network, which is kind of stupid to me. I think I can do multiple rungs in 1 network on a 12 or 1500 PLC, but on the older stuff, it doesn't want to work. So I had to separate these. So all I'm doing here is what I wrote down here, module. So the input module, I'm going to configure the channel pair EO or E0, E1 as function mode 6. So I need to send a binary code which represents decimal 6. And if you look at the input module here, it discusses it right here. That's where I'm setting the bits right now. You know, there's the decimal equivalent numbers there. And it also talks about what this represents and what you're configuring right here on this manual. So that's what this code is here doing from the first bunch of networks. It's just me configuring it that way. Okay. Next thing is the module-based passivation. I want to activate channel-based passivation. If you go back to the manual, it will right here. So channel-based is when you set it to 1, in which case I'm going to turn the bit on because my always on bit's always on. Same bit. 2 networks. So I'm turning this on, and you can see that there. The this one right here is just me. Whenever there's a fault, I'll use the acknowledge button to acknowledge that error. That is setting this bit right here, bit 0, and network 9 is whether you want test pulse active. I'm not using it, so Sorry, my bad. Now we're into the output card, the FVDO, and on the output card, you're setting up whether you're using the test pulses, but in our case we're not, so I could do without that code, but I'm just going to leave it in there. Maybe I'm using it for something else. Same thing here, and same thing there. So this right here is setting up for channel 1 and channel 2, whether you want to turn it on or off, in which case we're not using it here. So network 9 through 11 is not needed in this particular sample. The next thing is this right here, whether there's channel-wise passivation, which I'm using. That's another configuration. So now we've configured the cards, which will get downloaded every time you start up, and now we've got the e-stops to consider. So there are, instructions over here on the right under safety, and because I have an e-stop connected to the circuit here on the input, they're wired physically to these right here. Because the module itself takes care of all the diagnostics and the short circuit detection and so forth, then you only need the one to be used in the code. In which case, come on, this input right here is my input for the e-stop. The right here, what is this for here? Acknowledgement necessary. That just tells you whether it's going to auto reset or not. This right here tells me that acknowledgement is required. So if I hit an e-stop, for example, then the acknowledge required would be on. And then the push button I have on that non-safe input card is what resets it. So, and the output when the e-stop has been reset and then acknowledged is on the Q circuit right here. Now the next thing is the feedback circuit. So this is the circuit I have for the channel 0 power enable. So we've got a feedback block, which again is over here on the right hand side. You can, if you press the F1, you can get this little hover over here, or you can click on this and you get a better detail of it. And basically, the e-stop block here, like I said, the e-stop db.q, which is right here, is the output from the e-stop. When the e-stop's on, I want to enable the power. Simple as that. I don't want to overcomplicate things. And for the feedback part of the circuit, I need a inverted signal to the Q. So when the power enable goes on, this should be off, and vice versa. And in order to do that, I'm using the status of the module. So if I go back to here, go to the output module. So I have a channel 0 power enable and I have a power status. Channel 1, status. Channel 2, status. And when I turn these on, these will come on. It's a direct relationship. So we need to invert these. So the code I have here, if I go back here, I've just got this channel power status and I'm inverting it and using that into my feedback. And then this QBAD thing here, I'm not entirely understanding everything about it, but after talking to Siemens, when you come into the output card here, you have under FIO data blocks, you have this QBAD output, and this is what I'm using to tie into here. And then of course the acknowledge, and it has to, the whole circuit has to turn on, get the feedback within the 150 milliseconds. So let's simply save the project here and compile it one more last time, and then we'll dump it online here. All right, so We're 45 minutes in, and we're going to go online. So do a download. Nice and quick. I've already got a password that I've written in here before, otherwise you'd have to put the password in. Do a load. Do a start all. Okay, now let's go online. Move this down. Go online. And we have all greens, which is great. Everything's good. Okay, so let's show some things in action here. Go into a monitoring mode here. So this is on. So because this is configuration data, and because we've just downloaded this for the first time, at this point, I'm going to cycle power to the CPX manifold in entirely. The logic voltage and the load voltage. So the CPX manifold's off right now. You see there's a fault in the PLC there. Turn it back on. Now it's green. The fault was because it's loss of communication, right? Let's just do, well, let's do that again. So I'll turn it off again just to get the fault, just to show you what we're looking at here. Okay, so you come over here, you click on here. Diagnostic status, module exists, faulty, error, low-level component. Diagnostics buffer, we've got ProfiNet IO station failure. And what else can we look at here? If I go to the network here, it's not reachable. So I mean that's pretty straightforward. And then I'll turn it back on. It's powered up, and now they're gone. Okay, so great. So we're back to square one. So the one last thing I don't know if I covered. Let's see here if I covered it, if I even programmed it here. Yeah. So network 16 is the global acknowledge. So right now, the LEDs on the Festo maintenance tool project here. I'm just going to go back online here. So right now on this module right here, and on this module right here, both safe modules, there is an FP light. Okay, if I go into one of the manuals here, so the LED here, scroll in here a little bit. The top right LED right here, the one that's going one is the module error light, and then below that is item number 2, which is the FP, which is the fail-safe protocol. And right now on both the safety input module and the output module, they're flashing consistently, just on, off, on, off, on, off. One's flashing a little faster than the other, but basically that's it. And that's because we have not integrated the safety yet. And that's the purpose of the global acknowledge right here. So this is the reintegration. So I'm online here. And what I'm going to do is right now is this input right here, I'm going to turn this on and click the button one time, and it's now been integrated, and the LEDs I just referred to are now solid green, which is what we want. And get some screen interface face here. Okay, so right now we have an e-stop on, so I'm just going to press the e-stop here just so you see it go off. So the e-stop goes off right here, and I'm going to reset it. It's pulled out, but right now this queue is not on because we haven't acknowledged this over here. So I'm going to press the acknowledge push button again, this one right here, and you'll see that it turns on, and that's it. E-stop turns on, the acknowledge happens, the Q output of the e-stop gets turned on, the power enable gets turned on, the feedback inverts, and away you go. We now have a good circuit. And all I have to do is press the e-stop at any time, and you'll see that the channel 0 power enable drops out. And that's it. Nothing more to it. You can program the other channels in a similar fashion. This video is in no way showing you how to program safety, and you need to do it all yourself. This is a sample code. It's got nothing to do with your project or your application. This is just a sample to show you how you would go about doing something very minor. And simply, in this case, we're just turning on the valves that are on the manifold to give you an idea how things work in the Siemens and Festo world together. Okay, so my name's Steve Proud. I hope you enjoyed this video. Hopefully I wasn't too boring, and you guys have a great day.